In exercise 2b, we apply bagging. We will repeat the regression and the classification from last session with the student math dataset, but this time we will apply bagging to our card estimations. So first we need to install the package random forest, and then we will import this package. Now let's determine the number of features, which is 30. And now we can build our bagging model. So we use the random forest function here because a bagged model is just a random forest, or you could argue that it might be a random forest where you use all the features. So random forest, if you remember the lecture, and we will talk about it also later in this session, uses just a reduced number of the available features to make forecasts or to train every single tree, and then it combines the tree. And with bagging we don't do that, we still use all the features. So you can think about bagging kind of the reverse way as a random forest, but with the specialty that it's incorporating all of the features. So we need the number of features which is 30. Then the inputs are as usual our target and features. Then the data set, the number of trees I set to 1,000. I just I don't have any reason why I choose 1,000. I just did it arbitrarily, and so I need to set mtry to 30 because this is the number of features, and I set doTrace to 1, so it will return statistics for all the trees. Now these are out of bag statistics, but we are not interested in the single trees, we are interested in the combined model. And so if we just run the model name, then we get this return here, and we see that the mean squared error residuals, which are out of bag, are 9.11 or 9.12 roughly. Same goes for classification. Here I denoted the I chose to define a new variable dfc, so I could store the data frame again in this variable, and then I don't have to go back and forth between classification and regression with this data set. So then this is the classification data set. I introduced our y variable again as this the categorical feature with these 4 classes, 1, 2, 3, 4, which lie between 0 and 5, 5 and 10, 10 and 15, and 15 and 20. And yeah, I deleted the G1 variable from the predictors. Then we can build the bagging model for classification just as we did for the regression, because if the target is a factor, the random forest will automatically use a classification or use classification trees for the bagging model or the random forest model. All other inputs are the same, and then we can see that the return shows us the out of bag error rate and not the MSE. So this is 47.3, and we also see a confusion matrix which tells us for all the classes we have, when we predict it, what did we actually predict. So here for class 1, unfortunately, we have a very high or the maximum classification error of 1, so 100% of observations that were actually of class 1 were wrongly classified as 2 or 3. Then for class 2, this is much better. And also for class 3, this is better. Although there's a lot of confusion between 2 and 3. And for class 4, that's pretty bad again. But as most observations lie in or are of the class 2 and 3, the overall out of bag error is not that bad.